Hello, everyone, and thank you for joining today's session. My name is Irina, and I'm the event planner for the Redmond Reactor space. Before we get started, I have a few things to go over. Please take a moment to read our code of conduct. We seek to provide a respectful environment for both our audience and our presenter. We do encourage engagement in the chat, but please be mindful of your commentary, remain professional and on topic. Useful links will also be shared in the chat. This session is recorded and will be available in 24 to 48 hours on the Microsoft Reactor YouTube channel. Which brings us to today's session. This session will run approximately 1 hour with questions throughout, and our speaker today is Sam Wronski, who is a regional cloud advocate. I'll now turn it over to Sam.
Hello, everybody. I am Sam Wronski. I'm a regional cloud advocate here at Microsoft. My job is to help empower all of you to build awesome things with Microsoft technology. Today, we're going to be doing something a little bit more experimental. We're going to be exploring Signalr and how you can use that to build real-time web apps. This is not a tool that I am particularly familiar with. It's one that I have briefly used years ago. And so we're going to be picking it back up, learning what that is, and trying to implement something really quickly just to kind of build into that. So that is sort of the plan for the next hour. Hopefully this will give us a little bit of background about what it takes to actually build a real-time web app and what we need to do. And then hopefully we can also use that to kind of start planning some bigger projects that involve this same technology for things we'll do in the future. But for now, we just kind of need to figure out what this is. So what Signalr is a cross-platform library that allows you to interact with different things. And so it provides you with a series of hubs that you can then have clients that connect to. Those clients don't have to be based in .NET. They can be written in other languages as well. And then they will read events like an event queue from those hubs. And so that's how this works. We're going to be kind of running through the docs here just to kind of learn this, because again, this is not something that I am super familiar with. So the intent is kind of to show you, here's how I learned this, and here's how you can use this. Hopefully, if you have used this and you have suggestions on things we can try, things we should do, things we should explore, drop those in chat, because that would be super helpful. And you might help me and you might help somebody else in chat. So let's kind of dive in and see where we are. We're going to be relying on these Signalr Docs. You can find those at ak.ms/overview Signalr, and there should be a link in the chat. That will kind of help you find this and find a bunch of other docs that you can use. We're going to be kind of jumping around a little bit to get started. So what is Signalr? I think that's probably a good place to start. So we're going to kind of read through this introduction and then kind of jump around a little bit and maybe tinker with some code to learn more. My learning style might not be yours. So definitely check out that link if that's something, if you want to go in a different direction. But hopefully my style helps you a little bit. So Signalr is an open source library that simplifies adding real-time web functionality to apps. So this allows you to send code from your server or send data from your server to clients in a relatively real-time manner. So you can kind of push new updates to clients pretty quickly. Think about something like a chat app where you want to send new chat messages to all the users connected to that chat. This is how you would be able to do that. And that's an example. One of the things that's usually really nice to know about new technologies is what it's good at and maybe what it's not so good at. So we're going to take a look at both of those. So good candidates for Signalr. Apps that require high frequency updates from the server. So GPS, auctions, voting, social networks, and gaming are kind of examples that they give here. And I think all of those kind of make sense where you have gaming, where you have a live stream of maybe player scores or something like that. Social networks where you're intending to create something where people can interact in real time. Those make sense. Dashboards and monitoring apps, again, the importance there is trying to get data as fast as possible so we can actually iterate on that and learn from it as quickly as possible. Collaborative apps like whiteboarding apps where you share a whiteboard and remotely with your team and can actually iterate on that together across different places. And then apps that require notifications, where you can have a Signalr hub that sends those notifications down to all the clients so that they can see new emails, new chat messages, things like that. Signalr provides an API for creating server to client remote procedure calls. This is something that you might have heard of before. RPCs are not exclusive to Signalr. That's not a unique concept here. It refers to being able to invoke functions on a remote server. So in this case, sending a message saying, run this function and send back the result to me. So this gives you a way to do that. Another common one is gRPC. So those are sort of the two that I'm familiar with. I don't believe Signalr uses gRPC as its protocol. I believe it's using something else, but we'll learn that as we go through this. The RPCs invoke functions on clients from server-side .NET Core code. There's several platforms. Which platforms? Let's go and find out. Looks like JavaScript, .NET, and Java are sort of the big ones. So if you're using like Spring Boot, for example, that you would also be able to interact with these Signalr hubs. Or if you have a JavaScript or TypeScript web app, that should work as well. We're, I think, going to be focusing a lot more on the .NET side. That's a language that I know more, and maybe some Java if there's interest there. But for this, I think we'll probably stick to .NET and maybe use a Blazor front end, another technology that I'm not entirely familiar with, but it should be fun to learn. So let's explore. So let's see here. Each of these supported clients has their own SDK that you can use. So you can grab the SDK for each of these, and it will give you library native APIs that you can use to do that. That should integrate with whatever platform you're using. So it shouldn't just, it should feel a little bit more natural than what you're normally seeing. Some example features of Signalr for ASP.NET Core. All right, so it looks like this is a list of some of the features that you'll get with ASP.NET Core when you're using Signalr integrated into that. That's sort of the use case we're going to be focusing on. So this makes some sense here for things that we'd care about. It's going to handle connection management. So the way the Signalr works, there is a hub that is going to be, I've kind of started drawing connections to like REST endpoints. So it's not entirely the same that you would connect to. That is a hub that is going to be able to receive messages from clients and send messages to those clients. And so you don't necessarily have to do a send the messages out to every single client. You can actually find just clients that are tagged in specific regions or with specific user data, things like that. Send messages to all clients simultaneously for a chat room or something like that. Send messages to a specific client groups. So this is going back to that ability to pick specific people in those clients to send the message to. For example, just sending it to moderators, for example, in your chat app. Scales to handle increasing traffic. So I'm not entirely sure what that means. So we'll probably learn more about it as we get into it. I'm assuming that means it supports horizontal scaling, but I don't entirely know. So this one is a question mark for me. We'll come back to that as we learn more about this and start integrating with this. Because of the time limits and the size of the app we're probably going to be building and working with, we might not even get to this in the first place. That might be something much further down the line that we'll have to learn about more. And then the source is hosted in the Signalr repository on GitHub. So again, Signalr is open source. So here's the source. So you can go and explore that, raise issues or other things. But I don't think we need to get into that too much. This is our clients. We don't need that tab anymore. And then transports. So again, we're kind of learning the fundamentals of what this tool even is. So the transports are what supports the communication between clients and servers. So my understanding of Signalr is that you'll have a series of clients. So if we're talking about Twitch chat in this setting, or something similar to that, we will have all these different users who are watching this stream, who are looking and curious about, well, are there chat messages or something like that. Those chat messages will get sent up to a server, like a central server controlling those messages. And then from that server will broadcast those messages back out to every client. So this way the clients don't need to know or send messages to other clients. They send it up to a server, and then that server delegates that and sends them back out. So that's how this works. This is talking specifically about how those things are measured, I think. So WebSockets, I think, is how this does this. I don't know what long polling is. I feel like I used to, but I don't remember off the top of my head. So if we need to know what that is, we'll double check it. And then Signalr automatically chooses the best transport method that is within the capabilities of the server and client. So this makes it sound like Signalr is going to select different transportations types for different clients, depending on what makes sense. So I imagine WebSockets will end up being what we'll end up using, because we're going to be focusing on Blazor, but we'll see. And then hubs is something that I've talked about previously. So Signalr uses hubs to communicate between clients and servers. Servers declare hubs, and then those can be subscribed to by clients. So hub is a pipeline of messages. Signalr handles the dispatching across machine boundaries automatically, allowing clients to call methods on the server and vice versa. So this is going back to that RPC, or remote procedure call, that we were talking about, where a client can say, run this method, send that off with all the arguments and things to a server, and then the server can run it and send the results back, and trigger events across all the clients. So on calling methods on the server and vice versa. So this also allows the server to tell all the clients to run specific things. So show the chat message, or process this, or do this. You can pass strongly typed parameters to methods, which enables model binding. Signalr provides two built-in hub protocols, a text protocol based on JSON and a binary protocol based on message pack. So message pack is, I believe, another form of protocol buffer. So this looks like if you're unfamiliar with protocol buffers and what they are, think of it like a highly condensed binary stream of data. So instead of sending a JSON blob, which might have just a whole bunch of extra fancy things, you have a bunch of text and formatting and quotes and things that you might not need. Instead, what these are really good at is getting that data as small as you can. And so you might declare, we need a Boolean value. So instead of typing true as text strings into your JSON, you might type just 1 and use a bit for that. And so you can compress things significantly more into a message like this, allowing you to send less data over whatever you're trying to do. So there's a few different ways to do this. Protocol buffers is sort of where you would start looking if that was something you wanted to learn more. Can we send data across subscriptions? Are you referring to Azure subscriptions when you're asking that? And if so, I would assume so. What we're talking about here is not necessarily restricted to Azure. This is not a Azure thing. So there is a Signalr Azure pack, which is somewhere in here. Signalr.net. Let me go and find this. There's an Azure Signalr service that will host your hubs for you. I am not familiar with that service yet. So that's something that I still need to learn more about. But as far as that, I would imagine as long as you can subscribe to the host, you should be able to. But I haven't tested that. Again, I'm still learning this, so I can't really give you good answers there as far as what is and is not supported. because honestly, I don't know yet. So in this case, we're kind of exploring together and trying to figure this out. Yeah, I think that's the best answer I can give you there. Done with protocol buffers. Those are not a Signalr thing as well. I don't know if I mentioned that, but protocol buffers is not a Signalr specific thing. Message pack also, you saw, is just a separate thing. Now you have 2 tabs for it. But this is just a format to take a defined set of things. So in this case, I actually have an example here where they have the JSON blob that is storing a Boolean value for if the thing is compact, or a integer value for if it's a for what schema to use. And here you can actually see it's kind of compressed down into byte strings and just values. So you just end up with very small components in this entire thing. So that's the intended point of these, is to really get your network traffic down. So yeah, if that's something you need, that's there. And you can just start exploring that and using that without having to necessarily dive into all these other things. For example, if you use Kubernetes, protocol buffers are, I believe, supported by default in them. So you can actually switch over directly to that if that's something you want to do. Hubs call client-side code by sending messages that contain the name and parameters of the client-side method. So what this is telling me is that names matter. So I believe we're going to be passing the strings of the names of what we want to invoke between our client and our server in order to actually handle that communication. So we might want to take a look at some way to improve that messaging and have our names be a little bit clearer, or maybe find a way to remove the hard-coded strings that are going to pop up if we start doing this. Objects sent as method parameters are deserialized using the configured protocol. So again, going back up to the protocol stuff, the client tries to match the name to a method in the client-side code, and when the client finds a match, it calls the method and passes it the parameters. So what that's saying is sort of how all of this works. So a hub will send a message to a client. So if you send a chat message, for example, you're going to send a message that is going to have your username and it's going to have what you typed to say. And we want to send that out to every single client. So you're going to send a message that says new chat message with from username with message. And then every single client can handle that or invoke a function on their side that handles whatever that means. So in this case, probably adding it to a list of all the chat messages so far. That's how that would work. So let's jump into this, and I think just kind of poke around and see what we can learn. So there's a whole bunch here to cover. I'm not going to get into it or get into all of it because there's actually just a lot. So again, if you want to check out aka.ms/overview Signalr, that will get you to this page. You can go and jump through that and learn this, and also get access to these other links that we're going to be kind of following. So there are a series of tutorials here that will walk through how to do a lot of this stuff. So if we wanted to look at Blazor, for example, we could jump into here. We can choose the Blazor server or the WebAssembly side, and then walk through all the steps of setting this up. There also are samples. That's the wrong tab. But there's also sample code. So this is a GitHub repository that has a whole bunch of samples for us to use. Hello, everyone. Thanks so much. So in this case, I think starting from these samples and kind of building out from that makes sense. For me, that's sort of how I like to learn, is grabbing sample code that already exists and then seeing how my changes impact that. Because then you can actually see a working solution instead of starting from nothing. Do I know any breaking changes between .NET Core 5 and 6? I don't. Just to because it looks like we've had a few people join. I'm still learning Signalr. So this stream is sort of intended to show you my process of learning what this tool can do. So because I'm getting relatively um, since I'm relatively new to this, where I'm not entirely aware of all of those things. But yeah, no worries. There's no downside to sidetracking or something. That's the intent of this stream, is for us to kind of chat and learn things together. So you're doing exactly what we're hoping you will. So it's working. Yay. But also thank you. Because honestly, the chat messages are the best part of these kind of streams. So thanks so much. And hi, everyone. So Signalr is like an API. Yes. It's a little bit different, but similar, I think. So if you're familiar with like a REST API, where you have a bunch of endpoints that are doing different things, what Signalr does is give you hubs that are these message brokers that are going to send messages to and from clients and servers. The difference is that when you make a REST call, it's typically stateless. So you're typically sending something up to a web server, and then that web server is taking that thing and processing it, maybe requesting some information from a database or something, but it's typically isolated to that user. The cool thing with Signalr is it can immediately trigger event messages to be sent out to all sorts of different clients. So if we're having a chat conversation like we are right now, as you're sending these chat messages, there's a hub that's getting triggered to send these back out to people, which you wouldn't see for a REST call, for example, where you wouldn't necessarily know quickly who those other people are to send to, and then adding it to a database or something, and then they need to refresh the page to get the new information and make another web request. And so this kind of avoids that. Cool. So let's just clone this repo, I think. This is the Signalr samples repo. So hopefully we can go and grab things. Okay. Oh my God, Signalr. Yes. I never understood it. I've tried a few real-time communications between a .NET backend and an Angular frontend, but I couldn't. I'm assuming kind of get it to work. I've done Signalr once in the past, and it was a mistake. I may have pushed it a little bit too far into things it probably wasn't intended for, and created a bunch of architectural not great choices. So kind of trying to relearn some of this and pick up some of the new stuff. I think with Blazor and some of the new ways to do front end stuff, it's also really intriguing. And so the hope here is we're kind of trying to learn more about Blazor and Signalr and these kind of technologies, so we can build a full front end app that hopefully you can come and see in the reactors and kind of interact with themselves, so that our Microsoft reactors have cool tech apps that you can kind of play with, and we can build something from that. So hoping to kind of have an entire project built around this in May, but for now, trying to actually learn what the tool is and figure out how this works, and maybe anything that could help make it a little bit clearer, because this is definitely more complicated than just a REST API. There's a lot that can make things more complex when you're building an event-based system. That can cause things to get weird. So we're going to hopefully try to learn those. Yeah, cool. Let's clone this repo and see where we get. So I'm just going to do that. And let's clone this. Sure. We'll clone it there and see what happens. And so that gives us all of these samples locally. We can then jump into that. So let's go and open this. I was going to build a project from scratch. That's what this was going to be. I think that might be a mistake. So we're going to rely on some of these samples and hopefully learn from those instead. It's already open. Neat. That's not the right one. Sorry, getting lost in my terrible amount of projects. Also not the right thing. Cool. Signalr samples. Perfect. And let's jump into, I think we have the stock ticker. So I think this is the most recently updated one. Yeah. So we talked about this last week, actually. So there should be a video out on the Microsoft Reactor YouTube channel if you want to check that out. But you can create a shader for your background, your Windows terminal. And so that's what this is. This is actually entirely procedurally generated and just a cool shader that's animated over time. So that's how that works. Let's see here. Signalr learning. Sure. So yeah, there's a lot of cool things you can do with the Windows terminal. That one is under the experimental.pixel shader setting for your terminal. So you can just apply that across all your terminal windows. Yeah. So we get two apps here. So apologies if that's small on the right-hand side there. I don't think I can make that much bigger. So let's just open things and I'll talk through what's happening here. So there's two projects in this sample. There's actually three, but we can ignore the third. So there's a C# client, which is going to be our client that's actually reading. This looks a lot like a console app. So let's see here. Yeah. So what this is doing here, I'm just kind of walking through the code. This will be simpler than starting with the actual full web server part. So this is what a client looks like. In this case, it's creating a connection to our hub. So in this case, we have a server that's going to be running on localhost 5000, and that's going to have a hub located at the /stocks endpoint. And then we can configure our logging to actually log things out, and then add a message protocol, and then build that. So that's building our connection to our hub. And then we just start the connection. So that's what that's doing. And then let's see here. There's a cancellation token to cancel that. And then we can detect when it's closed. So if we ever close the connection, maybe shut down the server, it's going to let us know that the connection is closed. And then here, looks like these are our fun messages. So we have connection.on and then a string. That string is going to be the message that we're sending. So we talked about sending things through the hub. In this case, they are named functions that we're calling. So in this case, whenever a server sends us the market opened signal, we're going to get that message and we're going to automatically invoke this function. When we get the market closed thing, we're going to invoke market closed. And market reset, we don't do anything. So that's just ways to kind of log things out and attach to different things. And then what's happening here? The channel connection stream as channel async. Looks like we have something here to connect. I don't actually know what this is. So channels, I believe, are like event queues that will read events. I'm assuming of type stock because it's a generic. So this is going to read messages of this type off of that queue. This is where I've screwed up in the past, is using channels for things that they really shouldn't have been used for. I tried to replace an entire streaming data pipeline with these channels. I don't think that was a good choice. It got really confusing. I think we ended up rolling it back. But anyway, this gives you a way to kind of read these messages over and then invoke. I'm assuming invoking that when that happens. So method name invokes a streaming hub method on the server using the specified method name and return type. So this is going to invoke a method on the server by running this. And then what's happening here is we end into a loop. It looks like it's just reading these new messages that come back. So we subscribe to the channel and then we just wait to read for it. So that first message is saying, I want to read messages off of this queue. And then the next one is reading those one at a time off of that queue. And then while we're trying to read that, this is getting our stock value out and then printing out that stock value. So what we should see, hopefully, we'll take a look at how the server actually works, because that will determine what we see. But what we should see is we should see our starting connection. We should connect to our server. And then we should be able to close it with Control-C to actually cancel this entire connection. And then from there, we might get some market open and market closed signals that will print out to our terminal. But then we should start seeing stocks here, popping up here. So we should start seeing a list of stocks with a symbol and a price. So that's sort of what I'm hoping to see. Let's go and look at the server side and see if that's actually what's supposed to happen. So I'm not entirely sure. So this looks like it's a Signalr or ASP.NET site. So let's walk through that quickly. We may not need to see all of it, but we'll check. But I think of hubs like a physical Ethernet hub. One message gets repeated out to all ports, but in this case, channels. I'm not sure. What's a good example of a hub? Maybe like a train station or something is sort of what I'm thinking, where you have different paths and journeys that you might want to go down, but they'll be different things. They'll have different names, so you might have some track going one way and some track going the other way, and you might want to subscribe to the trains on that and watch those. I'm not entirely sure if that's a good analogy at all, actually, but I don't know enough about Ethernet to say yes or no. Maybe closer to a switch. But again, my networking knowledge is not very good. So that's unfortunately not an area that I have done a lot of work. So maybe I think I'm kind of seeing what you're trying to suggest, and so maybe that makes sense. We'll see. So what's going on here? We are constructing an ASP.NET website. So this is just an ASP.NET server that is going to do a bunch of things. First thing, create a host. I don't even think any of this is unique. Nope. All right, cool. Let's jump somewhere else. Here we go. So in our startup, we add a Signalr service. So this is actually creating the Signalr service for us. And then we add a stock ticker singleton. So we'll jump to that in just a second. And it looks like the only other thing we have to do is map this hub. So when you would map endpoints, this is mapping a hub to a specific location. And so if you jump back to our client, back here we have stocks. That's not the client. There you go. You can see we're actually subscribing to that stocks endpoint. So that's how that all connects. This stocks should need to match up with this one. And so if we change that, it should change as well. So then what's happening? We are creating this stock ticker singleton. So let's go and check what that's going to do. Looks like a lot of things. Got some semaphores here. So lots of concurrent stuff is going on. I don't think we need to know how this actually works. I don't think that's sort of the point here. So I'm intentionally going to ignore a lot of this because I think this is more a implementation detail than a Signalr thing. So we're going to try to skip over that as much as possible, just because diving too deep into concurrency might take a little bit more time than we want. So what's happening here? We have our stock ticker, which takes a hub context. So that's getting injected somewhere, probably the stock ticker hub. There we go. And so then we can get all stocks and stream stocks and open the market. What's this do? This attaches to that market and waits before releasing the state. So this is why we have those singletons or those semaphores, because we're doing something here that needs to be locked. And then we have default stocks here that are added, and then update stock prices. I'm wondering if there's more going on here than I'm realizing, because I think this might be doing a bit more. So anyway, we're going to skip some of that, but I'm seeing some things that I'm wondering if it's doing more updates than I think. Because again, this is my first time seeing this code. This is how I learn new things. I tend to find a relatively small open source project or something else that I can get the source to that I can kind of grab the code and tinker with, because then I can break it and re-download it and it's fine. And also it usually just gives you something that is actually like an example that is nicer than like hello world, because those can get they're less fun to do a lot of, but also they don't always get you into all the same different use cases. So finding things where people have actually implemented it and trying those, I've found, is a really good way to learn new things. So we're going to explore this. Where am I now? So we're in the stock ticker hub. So we saw that our stock ticker, this thing, scrolling all the way up, there we go, is using a stock ticker hub. So we're opening that. And then this gets the reference back to that stock ticker. And then it gets all the stocks, streams the stocks. So it looks like this is just a very small wrapper over all of those things. The important thing here is this is extending hub. So we should probably go on a quick detour because I actually know why this is doing what it's doing. But because the methods are declared in a hub object, these public methods are now accessible as things that can be invoked from clients. So we have get all stocks, stream stocks, get market state. These are things that can actually be sent to these hubs to actually run. So again, we mentioned these were going to do different things. In this case, this is actually going to run those functions. So this is like our public API. That's what this is serving as. So similar, I guess, to like a REST thing, but I don't know if I should be making that association, because this is very different. This is very much based on events, not based off of like single HTTP calls. So let's go, and this is our stock. This actually should match what's in our program. So if you were doing this, maybe a bigger application, you might split this specific symbol out into its own library and share that between your client and server. So you didn't need to duplicate this data object. But that's what that is. It's the same thing. And then we have an observable extension. As channel reader, I don't think we need this. Shows adapting an observable to a channel reader without back pressure. Okay. Let's go here. And let's actually just run this and see what happens. So we open this. We should be able to, let's start our server. So let's do Signalr samples. Make that a little bit bigger. So there we go. And let's jump into our stock. And I'm wondering if maybe making the stock ticker the default, the sample we're going to look at, maybe that wasn't the best choice. This seems like there's a little bit more going on here, but that should be okay. So let's run this. So let's jump into our server, I think. Actually, let's do this. Let's run the server here. So just running this, it's set up as the default project in the solution, so it should just start for us. And so that should give us our server side, and then we can connect our client and see what happens. So let's wait for that to start up and then jump into our, oh, we get a full website. I completely overlooked that. That's cool. This is going to be fun then, because then I can let's do some of whoops. Let's put this over there, and maybe throw this over there. Okay, that doesn't quite look great, but no worries. So now we have that. Let's run our thing to subscribe to this hub. So if we jump into our, where's the other thing? The C# client. We should be able to turn off caps lock and do .NET run. We might need to restore here, but so this should run our client side, which should subscribe to this. And so what we should be able to do then is open the market and see that happen, or get a whole bunch of errors. What happened here? Error getting the response from that. Let's try changing this, because I ran this application from Visual Studio, which changes the port that it's run on. So instead of running on port 5000, we are on port 5000 or 54,427, which is not what we want. So this is not exactly taking us where we need to be. So actually, let's do something even weirder. Let's put this over, not there, there. And then let's take this. And well, hold on. Sorry. I'm thinking the best way to show this. So we're going to do a bit of confusing things. Open settings, cool. Let's clear that and open another terminal. There we go. Can I? Sorry, I've completely blanked on how to split that up. So we're going to do something else. This will work. Sure. Let's do this. Apologies if this seems weird, because I didn't think this far ahead. Cool. So let's open that up. Code-n opens a new version of Visual Studio Code in the current directory. So we can just get that and throw that over there. I'm trying to be too conservative with my screen space, so let's not do that anymore. Let's do this. And create a new terminal. Cool. Anyway, apologies for that chaos. It's what I do. So let's go and start our servers. Let's go back up and jump into the server here. So cd stock pick our app, and we want to .NET run this. All right. Been all over the place, but that was cool. So it's a lot of warnings. What is this? Could not copy a bunch of things. Is this because we are running in Visual Studio? It might be. Let me stop that. All right, now let's try it. So all of those warnings were could not read or write to a specific location. That typically to me means that it's locked. And since those are in our compiled locations, that means that it's trying to write something and something is already using those files. So we can't override them. So for me, that means we need to do something else. This is still a very different port. Why? I mean, we can change it. So let's do that, because it should still work. So we'll switch that URL so that it will look at the new one that we have, and then try to run this here. Code gen, there we go, .NET run. So this should run our client and hopefully connect. It doesn't look like it did. So I'm curious what's going on there. Let's try the other one. Oh, I use the HTTPS endpoint. We want this one. That would fix it. Cool. Apologies for that. And so we get connected, and we even see some diagnostic messages come up on the other server side because we just connected. So we started our connection. We're connected. Let's open up our browser and jump into that. So here we are. Let's do this. My hotkeys all confused, but that's okay. So we have our stock ticker app on the right-hand side, and then we have our website here. So we should be able to start sending messages from our server to this client that we have. So if I start opening the markets, you'll see we get an open market message here. And we start getting messages of different updated stocks that we're tracking. So these are all the new updates that we're seeing come across. So that, I guess, is probably the best example we could have hoped for. So this is getting a bunch of those real-time messages from our server, pulling from this server running here, sending it to our client. This doesn't need to run on one computer. I'm doing that because this is a demo, but you don't need to run this on just one computer. It will work across them. That's the power of this. Now, we're able to send data from a server to be updated on a client in real time. In this case, we're updating just a console app, but you can also update websites, for example. Again, there's different things for your JavaScript libraries. For example, if you want to tie this into some front-end project that you have, that should work. So also, I closed the market, so you can see that that's marked as closed. Things have stopped updating. So there we go. All those are cool. The demo works. So you can actually go and try this. This is at that link. If you go and click on the samples, it's aka.ms/overview Signalr. That will take you to all the docs, and then you just click samples, and that will get you to the GitHub page that has all of these samples that you can go and try. There are a number of other Signalr samples. Lots of them seem to be chat apps. I'm trying to build something that isn't a chat app, just for some difference there. But here you can see it really doesn't matter what you're sending. In this case, we're not sending chat messages, even though it looks like chat, because we're just printing them out as console, but we're just sending data. So if we go and look at what's actually here, we're sending this. So we're sending a symbol with when it was open, when it was closed. That's not that. But like what the last change was, what the percentage of that was, what the price is. That's what we're sending here. So this can be pretty uniform. You can kind of mold it into whatever data you need to send to wherever you need to send it. And it gives you that way to kind of real-time communicate with them. So cool. So let's quickly go and look at a few other things, because that, I think, kind of covers most of what I had. If people have any questions or suggestions, I am in the middle of building something more complex for this. This was sort of I need to start learning this, so let's do that. And then now we can use this as a springboard to go and build some other stuff that'll be more in depth. But if there's certain things that people would like to see about this tool and how to use it, or examples that would be helpful to you, definitely let me know, because I can either find those or try to help build them. So yeah. Anyway, I thought this would be a cool thing to demo. Let's quickly scroll up here and make this bigger. There we go. So there's a bunch of other tutorials going on here to walk through how all of this stuff goes. So there's one for JavaScript, TypeScript, and Blazor. These will walk you through setting up the different projects. And then the other thing is you can kind of dive a little bit deeper into how some of this stuff works. So there's more information about the hosts and clients that we can actually read through, as well as server concepts, like really diving into hubs. The reason we didn't kind of start here is because this is a much more in-depth thing, and we wouldn't have had time to actually run much code. We would have just been reading text, and you can go and read this yourself. So hopefully that's a better format, I'm hoping. yeah, anyway, how to set up hubs. We can actually see very similar things to what we actually saw in the app that we were looking at in these samples. So again, we're adding the Signalr service directly to our ASP.NET project. And then we are mapping that hub to a specific endpoint. This one's using chat because they're setting up a chat server. We were using stocks because we wanted to do that. If we wanted, we could go and change what that is. So instead of using stocks, let's go and switch this. So we are going to use stock example. It's a different name, so it should be fine. So that's really what we're aiming for, is just something new. And then we can go in here and we need to change that as well in our startup. So instead of stocks, we're going to use a stock example. And then we can cancel this. It's like it doesn't like that very much. So let's. Interesting. So it's not accepting Control C, and I'm curious why. We do subscribe to that. So cancel key pressed. We're supposed to cancel that. I'm wondering if something is preventing us from actually canceling things, because we can't get our terminal back. That's cool. We'll just create a new one. So let's jump back to there. Development C#. And we want our stock picker. Cool. So we're back to where we started. If we jump into our client, we can look at that. We changed where we were going to actually subscribe to things, but we should still be able to run this again and still connect. So we're not really losing anything. We're just changing how we're connecting everything. So let's switch to this and just run .NET run. So we're going to restart our app. Instead of seeing that connecting to /stocks, we should see something else. We should be connecting to, it's not going to work. .NET run, awesome. And so if we run this, now we can see we're executing our endpoint stock example in our logs. So we've changed where that is. We're just going through a slightly different place. You can see where also it looks like there's some extra things that I may have skipped over previously, like this negotiate endpoint that gets added on. So we have stock example /negotiate. I'm assuming that's how the actual hub connection is created. But I would need to double check that more. And we also get some diagnostic info, so you can actually see how long it took clients to connect to these different hubs. And yeah, now we're connected again. So we can redo that entire example just using different endpoint names. So you could also potentially have multiple hubs. I'm not sure what the use case of that is, because you can send, just like we were kind of demoing, you can send different messages through these different hubs. So there might be different isolation layers that you might want to consider when deciding whether you create a new hub in your application versus creating a new endpoint to invoke. That's the wrong thing. We have two different editors open. This is weird, but you can invoke market opened or market closed. That's still the same thing. Where was it? Here we go. Let's look at our hub. That's a good place to start. But you can choose different things to invoke. So we have all of these different methods that we can invoke as sort of our API surface, or you can create new hubs entirely that are separate and would need to be connected to individually. So how you want to manage that, I'm not sure, but that would be a consideration that you might want to think about. And yeah, I think we're kind of winding down as far as things are concerned. If this is something that's super interesting to you and you want to see more of this, I'm planning to do an entire series on Signalr in May. So that will probably start at the end of this month. So if that's cool and you wanna see more about that, we'd love to have you in those streams. Otherwise, thanks so much for joining. And hopefully this is something that you can start using in your projects or start experimenting with and learning a little bit more about. I've always found these kind of like message passing things to be super useful. I'm a big fan of the actor pattern and being able to actually send messages in a push-based way from a server to a client rather than the client having to constantly poll to get updates, for example. You could theoretically do everything we did by having your client get into a while loop and constantly running a REST service or a REST call to keep pulling for new updates. This avoids a lot of that because you're only getting updates when new updates are actually available for you to receive. So hopefully something useful to you to play with. We do have a survey. It's on the screen now. This kind of tells us if it's good or not. We're trying to figure out if we should do more of these or less of these, or if we should change them up a little bit. So if we'd really love your feedback there. So if you would go and fill that out, there's an event code there, 15756, which will kind of let us know that you're coming from here. And if you want to see more of this, that would be a good way to let us know. Otherwise, feel free to ping me somewhere else, and I'd be happy to chat.
Thank you, Sam, and thank you everyone for joining. Have a good one. Bye.
Thanks, everyone.